Okay, this is homework 4-7. I'm going to post the full solutions, but I'll walk through the steps here as we go through. So we've got a function right here, f of x equals negative 1/2 x squared plus 18. And that is this function in green that you can kind of see. And I need you to use summation notation to figure out the area represented by these, looks like 6 different rectangles. So the left side height of those rectangles intersects with the function. So we're going to use that as our outputs, or the height. So, and we also conveniently count by ones. So each delta x is 1. So if you take the output, which is the y value, make that a little bit smaller, and multiply it by delta x, and then add up everything, each one of these rectangles. So from x equals 0 to 5, and I'm saying 0 because if we think about it this way, like when x is 0, that takes us to that output up there. When x is 1, it takes us to this output. So we basically do 0, 1, 2, 3, 4, 5, and that takes us to all 5 rectangles. I'm going to show a different way to write the same answer in a second, but this will work. Okay, now what is the f of x is this function, and delta x is 1. So we can basically just go like that. I think in class we might have put, the 1 right here, the delta x first. On a few problems, it doesn't really matter. Either way, it's 6 different rectangles. Now, we could do this same problem. Let me see if I can do it in perhaps orange. Another way to do this. So let me erase these marks. You're not going to be required to do it multiple ways, but I just think it's helpful to think about it in 2 different formats. So let's say we'll start when x is 1. We want to take x equals 1, but we want this point up there. So that means that we need to take our function, write it this way, and before we even apply the function, we're going to subtract 1. That way, it effectively takes us to an input of 0 for our first step. And then that matches up with this spot right at the top there. So if, when x is 1, that gives us the first rectangle. When x is 2, it gives us the second rectangle. 3, 4, 5, 6. So here, alternatively, we could say from 1 to 6, but we need to use that x minus 1. So this becomes, similarly before, delta x is 1, so we can just say 1 times. And then the function here, we're going to put negative 1/2 x squared, negative 1/2 times x minus 1 squared plus 18. Either way will work. So this is correct. Also, this is correct. And on the quiz, I'm going to have multiple choice. We'll probably have the type like this on multiple choice, so you don't have to worry about those subtracting techniques. But it's kind of nice to take a look at it here. Okay, the definite integrals. So for problem 2, I'll use a different color here. How about purple? So we have to figure out what is the antiderivative of f at 10 and minus the antiderivative of 3. So what is the antiderivative? Well, the antiderivative means when we take the derivative of the antiderivative, I get back to the original. So the question is, becomes, what's the antiderivative of x squared? Well, you basically raise the exponent 1 and then multiply it by the reciprocal of the antiderivative exponent. Plus 2 times, okay, this would have an exponent of 2 times the reciprocal of that, the reciprocal of that new exponent, plus 5 times x to the first, so just 5x, plus c. Now, we don't really care about the c because we're doing a definite integral situation, so I'll leave it here for now because this is, the antiderivative, so that's fine to have there. Okay, so let's look at this evaluation now. So f of 10, antiderivative, minus f of 3. So this is 1/3 times 10 cubed plus 2. Geez, I'm looking at this. 2 times a half. Those can just cancel out. So I'm just going to keep it simple and say 10 squared plus 5 times 10. That's the first function. Minus 1/3 of 3 cubed plus 3 squared plus 5 times 3. Okay, I'm going to do this. You can't see this part, but I'm going to type this all into my calculator so I can just get this done. 1/3 times 10 cubed plus 10 squared plus 5 times 10. I did close parentheses minus open parentheses 1/3 times 3 to the third power plus 3 squared plus 5 times 3. And this is 450.3 repeating. How about over here? What the heck is the antiderivative of cosine? So my function for part B is cosine. So what is the antiderivative? Well, the antiderivative is when I take the derivative of the antiderivative, I should get back to cosine. So I am looking at the derivative of sine is cosine. So the antiderivative is sine. Okay, we use different color here. So the antiderivative is sine plus c. Now, when I do definite integrals, the plus c doesn't really come into play, but we'll just, for consistency, I'll keep that there. So antiderivative of x equals pi over 2 minus the antiderivative when x is negative pi over 2. So this is saying I want to find the sine of pi over 2 minus the sine of negative pi over 2. Okay, so I'm going to draw a little picture of sine. And I'm going to just make a quick note. When sine is pi over 2, that's this output, which is positive 1. When sine is negative pi over 2, the output is negative 1. So I'm minusing negative 1. This comes out to 2. So the answer to part B is 2. And now indefinite integrals here. Let me use that hot pink. Oh, so now we're looking at U substitution. So let's do part A here. So let's let U equal 2x plus 1. So du dx equals, oh, what am I saying? Sorry about that. Sometimes that happens. As soon as you start doing it, you realize you picked the wrong value for u. So x squared plus x. So du dx is 2x plus 1. So du equals 2x plus 1 times dx. All right, now 2x plus 1 times dx, that's right here. So I can say that I'm looking at the integral of, and that's equal to du, and this right here is u. So I have u times du. So what is the antiderivative of u? That would be u to the second power times 1/2 plus c. And now I'm going to resubstitute back in. So 1/2 of x squared plus x squared plus c. That's my answer to part A with this kind of side work there.